Alrighty, as we move through Chapter 5, we next come upon Section 5.3, where we add, subtract, and multiply polynomials. So the good news is that when we add and subtract polynomials, all we need to do is combine our like terms. And remember, if they are like terms, they're going to have not only the same variable, but also the same exponent. So you can combine 2x squared and 3x squared, or negative 5x to the fifth plus 9x to the fifth. When we multiply polynomials, we use double or triple or however many times you need to distribution, right? So when we have a binomial times a binomial, we know that as foiling, right? First, outer, inner, last. Well, we can extend that beyond a binomial times a binomial, as you'll see later on. So, in example 1, as we perform the indicated operation and put our answer in standard form, we are just adding two polynomials straight up. So all we need to do is combine our like terms. So I have 4x cubed minus 7x cubed. I have negative 3x cubed. Then I've got plus 4x squared plus x squared. I've got 5x squared minus 3x plus 5x plus 2x, they snuck in there. So I have 4 x's all together. And then I have plus 10 minus 5. I have a plus 5 at the end. Now, why did I jump out of order on my second polynomial? Well, as I'm going through, I know my answer needs to be in standard form, so I just look for my highest exponent, which is the greatest degree of my sum. So I had 4x cubed in my first one, so the degree of this first polynomial was 3. The degree of my second polynomial was also 3. So that's why I started with my x cubed term. We aren't able to combine anymore because I don't have any more like terms, so we are done. In example B, we have to be a little bit more careful because we are subtracting. So when we subtract, I always start by distributing the minus sign to every single term. So our first polynomial stays the same, and while we're at it, we might as well write it in standard form. So we'll write it in order of decreasing exponent. So 3x to the fourth minus 5x cubed plus x squared minus 9x plus 9. And then I have minus 4x cubed minus 8x to the fourth minus negative x to the sixth, or plus x to the sixth, minus 7x squared minus 9. So as I combine my like terms, I'm going to look for my greatest degree, because that's going to be the term I need to write first. And it looks like I've got 1x to the sixth, so he goes first. And then I don't have any x to the fifth. I don't need to write in plus 0x to the fifth. You're welcome to if you want. We just usually don't. So then we jump down to our x to the fourths. So I've got 3x to the fourth minus 8x to the fourth. I have minus 5x to the fourth. Minus 5x cubed minus 4x cubed. So negative 5 minus 4, negative 9x cubed. Plus x squared minus 7x squared, so minus 6x squared altogether, because remember we have the invisible coefficient of 1, so 1 minus 7 gives me negative 6. And then lastly, minus 9x, and I say that was last because I have plus 9 minus 9. Those just cancel out entirely. I don't need to write a plus 0 at the end. I am all done. In example C, I have to go a little bit one step beyond just distributing the minus sign. Now I'm distributing a negative 4 to everything in my second polynomial, which is totally fine. So my first one appears to already be in standard form, which is great. So 9x to the fifth minus 2x cubed plus 5x minus 1 minus 4x cubed minus 24x minus 44, and actually it's minus negative 44, sorry, so it's a plus 44 at the end. We combine our like terms. Let's see, my highest degree would be 5, so I have 9x to the fifth, and then I have no x to the fourth, so I move on to my x to the third, so minus 2x to the third minus 4x to the to the third. I have negative 6x cubed plus 5x minus 24x, that's a minus 19x. And then lastly, we have minus 1 plus 44 plus 43. And we're done. Now in example D, I am taking a binomial times a binomial. So we get to use our FOIL method, or double distribution, if you will. Now we need to keep in mind our exponent properties. This is why it's important that we started our chapter 5 with exponent properties. Remember that if you have x to the 8th times x to the 7th, as we will, we add our exponents. Okay, so whenever you are taking two bases that are the same and you're multiplying them and they have different exponents, we are going to add our exponents. We are not taking one to the power of the other, so I'm not multiplying exponents, I just add them. So I multiply my firsts. 15x to the 8th times x to the 7th. I have 15x to the 8 plus 7 is 15. My outsides, I have 15x to the 8th, 4x to the 5th. I have 60x to the 13th, because my exponents become 8 plus 5. And then negative 11x cubed times x to the 7th minus 11x to the 10th, adding those exponents. And lastly, negative 11x cubed times positive 4x to the 5th. I say minus 44x to the 8th. I take one quick look at my degrees on x to make sure that they're in standard form, and sure enough, they go in decreasing order. X to the 15th, x to the 13th, x to the 10th, x to the 8th.